Okay, we're going to talk about evaluating expressions. So basically what it is I'm going to tell you what something is equal to, what variable is equal to, and then we're just going to substitute it in and solve it. So I'm going to say evaluate the expression when x equals 3. Alright, so the first problem would be 9x. That really means 9 times x. So we're going to say 9 times 3, and that equals 27. Okay, the next one, if we have 12 divided by x, I'm going to take 12, and x is still 3, and I'm going to simplify or evaluate it to x 1. So we're still going to say x is equal to 3. And the third one, we're going to say x plus 4. So we're going to substitute in 3 plus 4, and that gives you 7. Number 4, 15 minus x. So we're going to say 15, subtract 3, and that gives you 12. Okay, so now I'm going to give you one to try. We have 10x, and this time I'm going to say when x is equal to 2. Give you a second, so that's 10 times 2, and that equals 20. So the next thing we're going to look at is exponents. Okay? So an expression like 3 to the 4th is called a power. Okay, for example, let's look at these pieces here. 3 to the 4th power. This right here is called the base. This is your exponent. And to simplify this, or to break it down, I should say, 1, 2, 3, 4. It means to multiply 3 by itself 4 times. And these are called your factors. So let's look at some examples. So 3 to the 1st power. It's read 3 to the 1st power, it equals 3. 3 to the 2nd power, or we can say 3 squared. That means 3 times 3, which equals 9. 3 to the 3rd power, or 3 cubed, means 3 times 3 times 3. So 3 times 3 is 9 times 3 is 27. If I have x to the n, we say x to the nth power, and this one's represented by x times x. We do these little things here. This means and so on times x. Okay, so now we're going to evaluate. So here's our expression, and we're going to say when x is equal to 2. So x to the 4th power is really going to substitute the 2 in, and it's going to be 2 to the 4th power. That means 2 times itself 4 times, once, twice, 3 times, 4 times, and that equals 16. Next one, we're going to evaluate when a is equal to 2 and b is equal to 3. So the first problem, a plus b squared. So we're going to substitute in a is 2, b is 3, and it says to the 2nd power. Inside parentheses, 3 and 2 is 5 squared, and that equals 25. The next one, sorry, we got a squared plus b squared. Notice this is different. So we're going to substitute in 2 for the A, plus 3 for the B. And we're going to square the 2, which is 2 times 2 is 4. And 3 times 3 is 9. 9 and 4 is 13. I have to do that one again. Sorry. I'll show that one again, because it was way over there. So we have A squared plus B squared. Make sure it fits on here. I'll put it underneath. And we said A was 2 and B is 3. So we're going to say 2 squared plus 3 squared. I'm just doing it again because we didn't have enough room. That's 2 times 2 is 4, plus 3 times 3 is 9. 9 and 4 is 13. Okay, next problem. We're going to say x is equal to 5. For the first problem, 3x squared. Remember, this is written as 3 times x squared. So x is 5. So 5 only goes in where the x is. So we're going to say 3 times 5 squared equals 3 times 25 equals 75. We're going to keep the x equal to 5. And we've got a new problem, 3x squared. Notice this one looks a little bit different. This is 3 times 5 and then 70 squared. So 3 times 5 inside parentheses, and we're going to square it. And then we get 15 squared, and it's 225. Okay, we also need to look at examples of, let's say, if we had negative 2 squared. To write this, we would say negative 2 times 2. This would give me a negative 4. But if I have parentheses around this, that means the negative sign and the 2 is being squared. So we'd say negative 2 times negative 2, and that would give me a positive 4. So let's take a look at negative 2 to the third power. That would mean negative 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, and I have one negative sign. But as soon as I put that, well, actually this one, when I put this in parentheses, I'm going to say negative 2 times negative 2 times negative 2. A negative times a negative is a positive, times a negative is a negative. Okay? So take a look at when it has a positive exponent, and an even, I should say, and then an odd exponent. Okay, and we're going to talk about the order of operations. So you have learned in the past with PEMDAS, which is parentheses, exponents, multiplication and division, and addition and subtraction. Sometimes I've even heard it as GEMDAS because they have the grouping symbols. Okay, so the rule is, first do operations that occur within grouping symbols. First, do operations that occur within grouping symbols. That's the first step. Second step. Then evaluate the powers. And we know that as exponents. A third, then do multiplication and division from left to right. Then do multiplication and division from left to right. So whichever one comes first, you need to do. Okay? From left to right. Okay, you can see that. And then the last step would be, finally, do addition. And subtraction. From left to right. So those are equal also. Okay, let's do some examples. So an example would be 32 divided by x squared minus 1. We're going to say x is equal to 4. So let's substitute in first 32 divided by 4 squared minus 1. Okay, so according to the order of ops, we have to do the exponent first. So we're going to say 32 divided by 16 minus 1. The next thing is we have division. So 32 divided by 16 is 2 minus 1, and that equals 1. Okay, let's take another one. So x equals 2. We're going to evaluate this. And the problem is 2x squared plus 1. Let's substitute in first. 2 times 2 squared plus 1. So this is 2 times 4 plus 1. Multiply, and we get 9. Okay? Now we're not going to substitute. We're just going to use the order of ops. So 15 times 2 divided by 6. Okay, so working from left to right, we have multiplication and division. Multiplication comes first. So 30 divided by 6, and that gives you 5. Next problem, 16 plus 4 divided by 2 minus 3. Addition, division, subtraction. So division comes first. 4 divided by 2 is 2. Okay, now we have addition, subtraction. You work from left to right because they're equal. So 18 minus 3, and that gives us 15. Okay, next problem. 1 plus 2 divided by 4 minus 1. We can write this on top of each other because it's kind of like a fraction, right? So we're going to say 1 plus 2 divided by 4 minus 1. And that's going to give us 3 over 3. And that is equal to 1. Next problem. 7 times 4 divided by 8 plus 7 squared minus 1. So we can do the numerator. It's 28. And in the denominator, we have an exponent. Let's take care of that. And now in the denominator, we have addition and subtraction, so they're equivalent. So I'm going to work from left to right. And let's add those first two first. Could add them all together if we wanted to. And 28 over 56, and then we're going to reduce that to 1/2. Okay, now I'm going to try a little more substitution. So I'm going to say x is 2, and 3 plus 2x to the third. So we're going to say 3 plus 2 times 2 to the third. And we've got to do our exponent, so 3 plus 2 times 8. Now we have addition and multiplication. We do the multiplication. So 3 plus 16, and that equals 19. The next one, I'm going to use p equals 5. So our problem is 6 times 2p squared. So it's 6 times 2 times 5 squared. 6 times 2 times, going to do the exponent, 25. I'm just going to multiply them all the way across, and you get 300. Okay, the next thing we're going to look at, because we're going to do all of them together, is absolute value. Okay, so absolute value is never absolute value is never negative. Okay? Absolute value is the distance, or how far away from 0 does that number lie. So you're looking at the origin, which is 0, on a number line, and if it's -7, it's still 7 spaces away, or 7 units. And if it's the positive 7, it's 7 units away. Okay? So let's look at some examples. So